Okay, so we're going to start our first proof. We're going to look at a union problem. So I want us to prove that the union from n equals 1 to infinity of 0, 1 plus 1 over n, the union would be 0, 2. So remember, we have to show that two things to show two sets are equal, that both sets is a subset of the other. Right? So let's start. We're going to do the first part of our proof. We're going to show that the union is contained in the set 0, 2. So in these videos, I'm only going to do the outline of the proof. I'm not going to formally write it up, but let's go with the start of this proof. I need to let x be in the union and then what do I need to conclude? What's going to be the end of my proof? The end is that x needs to be in the interval 0 to 2. So down here, the end of my proof, I'll make sure to try to give myself enough room, is that x is in the interval 0 to 2. So let's work backwards. What does it mean for x to be in the interval 0 to 2? It means x needs to be bigger than 0 and x needs to be smaller than 2. Okay. All right, so let's go back to our start now. To be in the union, remember it means that you have to be in one of the sets. So x has to be in the interval 0, 1 plus 1 over I for some integer I. For some natural number I. And what does it mean for x to be in this interval right here? It means that x has to be bigger than 0 and x has to be less than 1 plus 1 over I. Well, we've already got half of what we needed to get. If you look, I needed x to be bigger than 0, and that's what I've already got. So all I do is have to take this other thing on the right here, and I need to somehow get that x is less than 2. So let's think about this, right? I, the integer I, is greater than or equal to 1. The smallest natural number is 1. So I is positive. I can divide this inequality by I. So 1 over I is going to be less than or equal to 1. Let's flip it the other way around. I don't think I left myself enough room, but that's okay. So I don't just have 1 over I have 1 plus 1 over I. So I'm going to add 1 to each side of this inequality here and get that 1 plus 1 over I is less than or equal to 2. So what I'm going to do is I'm going to combine this inequality with the one up here. So if I write them together, x is less than 1 plus 1 over I, and 1 plus 1 over I, it's less than or equal to 2. So in the end, if I combine this into one line, it says x is less than 2. And that's exactly what I needed to get to here. So now that I've sketched out the proof, you can formally write it up. But let's go ahead and skip that for now. And we're going to prove, we want to prove that these two sets are equal, so I need another part to my proof. I need to prove that the interval 0, 2 is contained in this union. So how will the outline of the proof look like? We're doing the outline. What do I start with? I'm going to start with an element, let x be an element of 0, 2. And then what do I need to end up saying? I need to end up saying that x is in that union. So I'm going to leave myself some room. The end of my proof. The end of my proof will say that x is in that union. So again, to be in that union, it means that that element, x, has to be in one of those sets. So it has to be in 0, 1 plus 1 over I for some I in the natural numbers. And so I know that x has to be bigger than 0 and x has to be less than 1 plus 1 over I for some I in the natural numbers. So we're going to try to go back to our start and work our way down to this. Okay, so let's go back to our start here. If x is in the interval 0 to 2, well then I know that x is bigger than 0, and I know that x is less than 2. Well, I've already got part of what I needed to get, right? I needed to get that x was bigger than 0, which I did get. And then I need to show that x is less than 1 plus 1 over I for some I. So I need to find a specific value for I where that inequality would be true. Well, what if I let I equal 1, right? If I is 1, x will be less than, we said it's less than 2, so it's less than 1 plus 1, and that's the same thing as if I equals 1. So you should let I be 1, and if I is 1, this inequality would be true. So again, we're just sketching the proof right now, and we filled in the second part. So now you can go and write this proof up formally.